introduction. Good afternoon, everybody. Thank you for showing up to this presentation. And today I would like to talk with you about light. We shine a light on turf. But before we start talking about that, I would like to introduce our company, Stogger. Many of you heard about Stogger in the past 5 years, but we have made a video to give you a good impression.
Founded in 2016, Stogger is a dynamic company with around 50 employees serving 4 key market segments: Stogger Controls, turf care, signage, and innovation services. Stogger Controls is a global leader in wireless lighting control for horticulture, illuminating plants across an area of more than 500 football fields. These systems help growers improve crop management and energy efficiency, enabling more sustainable cultivation. Stogger Turf Care provides advanced solutions for sports turf management, working with leading clubs such as KRC Genk, FC Basel, and Bayer Leverkusen. Its lighting systems keep pitches in top condition year-round, enhancing playability and turf quality. Most recently, Stogger secured its first World Cup stadium project in Vancouver, marking an important milestone in its international growth. All processes, from design and engineering to production, customer support and sales, are handled in-house to ensure quality and innovation. In 2024, Stogger moved into a state-of-the-art facility in the Brainport high-tech region of the Netherlands, fostering innovation and supporting continuous growth.
So, talk about light. So, how does light affect turf growth? And if we take a look into that, the key process of plant growth is essential. Light, whether it comes from the sun or from a grow light, triggers the photosynthesis process, and together with the absorption of CO2 and water, sugars and oxygen are produced. That's happening during the day. At night, the cellular respiration process starts, and basically the process is reversed, basically meaning that sugars produced during the day are being consumed to make sure the grass recovers from damage, for example. This process is essential. Often we are asked the questions, do you recommend us lighting the pitch 24 hours a day? And because of this, we recommend don't do it. Do it at a maximum of 20 hours per day, and then make sure the turf gets 4 hours of rest. If we then take a look at for which light turf is sensitive to, then we see here a chart. We see the pigments here, pigments that are present on the leaf of a turf, for example, chlorophyll, carotenoids, and we see here that these pigments are different, sensitive to each wavelength, meaning that, for example, chlorophyll B, as you can see here in the chart, it's very sensitive to light of, for example, 460 nanometers, and much less sensitive to the light of 550 nanometers. This is important to understand, to know which light you need to provide to make sure turf grows and recovers. In the past, if you look at the chart, the HPS light source was the main form of lighting. And as you all know, HPS light is light that has a yellow-greenish color. Yellow-greenish color is here in the middle. It's between the 500 and 600 nanometer bandwidth. Unfortunately, turf is not very sensitive to this light, meaning that you need a lot of energy to create growth. With the introduction of the LED and the development of the LED, we are able to purchase LEDs, LED dyes, which emit a specific wavelength. And one of the main producers of these LED dyes is Osram from Germany. And their main goal is to produce LEDs at a specific wavelength at a maximum output. So what they want to do is to create a highest yield. So you need less energy with more growth. Big advantage is that we can purchase those LEDs, or at least Mechatronics, our lighting partner, purchases those LEDs. They put them on a LED engine. This is, for example, a LED engine built into this huge fixture. And together it forms a light recipe. And the balance between all these colors of LEDs makes that specific light recipe. Additionally, it's also possible to control those individual bandwidths of light. So you're able to control light and control plant growth. So we just learned that plants are sensitive to different wavelengths of light. So why should we aim then for multi-channel light control? What are the specific effects of each wavelength of light on turf growth? For example, blue light. Blue light is, for example, very efficient to open stomata. Stomata are present on the leaf of a turf, and once the stomata is closed, nothing happens. So you can light whatever you want. Under favorable conditions, the guard cells around the opening of the stomata swell if they, for example, receive blue light, and that opens the stomata, which basically allows, like a human mouth, the mouth opens and it allows for the CO2 to enter into the plant and the oxygen to go out. Also, water can go out, vapor, basically being able to control temperature inside the plant. Blue is also a color, as we just seen. It's very effective within the photosynthesis. So if I would provide you an amount of energy when blue, it's much more effective to grow this plant compared to a green color, for example. Also, with blue light, you can create a darker green color of the leaf, but also you can create more vegetative, compact growth, because in the end we want big leaves, compact grass, not very thin and very tall grass. That's what we want to achieve. Carotenoids, also pigments, just like chlorophyll, present on the turf's leaf, and basically this is an additional pigment. Also, when the carotenoids receive the light, they transfer basically energy to chlorophyll molecules. The nice thing about these carotenoids is that they are sensitive for a different wavelength of light, so this allows the plant to absorb a broader wavelength of light. It also supports the photoprotection, basically meaning that if you add a lot of light to turf, you can also damage grass, because it can't able to handle all this energy. By adding the yellowish-greenish light, basically stimulating light towards the carotenoids, it helps to protect against the excessive light. It influences membrane stability and makes sure that it's better for stress resistance. So that's basically in the range of the yellow-green light. Photosynthesis in the lower leaves, it penetrates a little bit deeper in the crop. Efficiency is improved. There's a relatively neutral influence, but it's very important for the balance. So what we are trying to do, on one side we're trying to create maximum growth, on the other side we try to create a healthy plant, and by adding a broader range of light we can create healthier plants. Red light, most efficient wavelengths for photosynthesis. That's why typically most in greenhouses you see the purple, the violet light. It's a mixture between red and blue, causing violet light. Very effective wavelength for photosynthesis. Together with blue, so only red makes a very thin leaf. Together with blue, you can create big leaves. And also the root growth in combination with the blue is enhanced. Far red light stimulates also the circadian rhythm. So for example, if at night the sun goes down, it's not the same light emitted when the sun goes down than in the middle of the day. Everybody knows the red skies. So when a plant receives the far red light, it perceives that it's in the shadow. So then it knows it has to go to sleep, and it wants to create a little bit lengthy to survive, to catch light. The Emerson enhancement effect, also here by adding far red light, the plant, together with red light, the plant is able to accept more light, to convert this into photosynthesis. If you would do this separate, so only red and far red, then it's less effective. So also here we see with light and adding, for example, far red, we can create healthier plants that perform better and better, have a higher resistance to diseases. So, evaluating LED fixtures. So you're going to purchase an LED grow light. What are the key factors and best practices? First, you can choose for a fixed or compromised LED spectrum. It's all day the same light. You can't change it. Or take a dynamic light spectrum where you can adjust the light based on what you want to achieve, but you also can mimic the circadian rhythm, which is a natural habitat for grass. We also can influence plant morphology. And you're ready for the future. LED efficiency binning. So we just taken a look at a LED engine. So the LEDs which are on, obviously everybody wants to have the LEDs on that have the highest efficiency. Unfortunately, if a company like Osram, which is leading in the horticulture market, is producing, for example, 25 million LEDs, not each LED has the same efficiency. Unfortunately, that's what they wanted. So what do? They categorize them. They categorize each LED, and they categorize them in A binning, we call it a super binning, or an F binning. A difference between the A and the F is 5 to 10% typically. To get these super binning LEDs was also for our lighting partner Mechatronics in the beginning a challenge when they entered the market, because they knocked on the door of Osram. They said, well, we have a lighting fixture, we want your best LEDs, and then they tell you, it's not going to happen. We have already made a reservation for them for our biggest customers that are the top sellers of grow lights in the horticulture market. So they had a big problem because they were losing 5 to 10% on efficiency, and you can't lie against a grower because they only calculate, they buy basically photons of light and they convert it or they look at the cost of energy, and if the balance is not there, then you lose. Then the price of the armature, the fixture, is not relevant. So over time, because they've grown bigger and they made good agreements, Mechatronics is one of the bigger customers of Osram at the moment, securing the super binning LEDs, which gives us a big advantage in the market. We also could have decided to develop our own light fixtures, but due to reasons like this, it's not feasible for us to do that. Lens technology. So we have an LED, and if we don't put a lens on it, it's very difficult to direct the light. So often a lot of light is ending below. So we can buy a lens for that. So There are multiple amount of lenses in the market, or at least made from different materials. On the left, you see a PMMA plastic lens, allowing for a lens per LED. So you put on a lens per LED to spread the light. Unfortunately, up to 7% of the light is already lost in the lens on day one. Additionally, the problem with plastic is that it can yellow over time, or it can be blackish over time. So even blocking more than 7% of the light. Mechatronics, also on the lights here in Basel, in the past used glass total forgot the name, but they used round lenses, and they are made of glass. Why glass? Because it doesn't yellow over time, it doesn't go blackish over time, and it absorbs less light, so we already win another few percent. Nowadays, you see the picture here of mechatronics, and you see a flat glass, flat lens, basically. And that is because the latest generation of Osram LEDs is the P37 LED, and the P37 LED of Osram has already the lens on the LED, so you don't need an additional lens, because in any case, the lens is over the LED to protect it. And the flat glass also makes sure that less light is lost. Due to all these innovations, compared to our last year's LED fixtures, developments are going super, super fast. We can't, almost difficult to cope with that. We have an increase of 18% in the latest generation of LED lights. So today we can offer 18% more light for the same amount of energy compared to last year. It's going super, super fast. All details matter. So, LED lifetime. A lot of people think that lifetime of LEDs, or at least heat of LEDs, LEDs do not run warm. That's not true. If I would put electricity on this LED engine, I think it runs up to 200 degrees centigrade, a lot of power. So what do? We're trying to cool the LEDs with a fixture, with a cooling body. The better we cool, the lower the temperature, the longer the lifetime. So we see, for example, if I would run at, for example, just at 200 degrees, but if I would do it at 105 degrees centigrade, then lifetime of the LED would just be above 10,000 hours. 10,000 hours, and after this 10,000 hours, only 70% of the light output is there. Today we are able to cool it down to 45 degrees. So we are able to only lose 10% of light over the first 75,000 hours. So basically, the better you cool an LED, the longer lifetime, the higher the light output. So basically, better growth, less cost. Thermal management. You can choose for example, an active way of cooling. For example, a ventilator, a cooling fan. And typically that's done to limit the amount of the heatsink, the cooling body. The problem with active cooling is that it consumes energy, and second, when the ventilator stops working, which is typically the first thing that goes bust, then the temperatures run up very high and lifetime gets very short. So although you might see the LEDs burning, you're wasting a lot of energy. So there's also the choice to make for an advanced thermal management system, which is basically a cooling body, and I can show it here. It's basically comparable to a radiator of a car. It's a heatsink, and within that heatsink there are also added heat pipes. Heat pipes are inside. They're also inside your iPhone, with the goal that if a lot of heat is produced on your chip when you're driving on Google Earth or Google Maps and you're also calling, then the processor needs to cool down as fast as possible. So we added these heat pipes also in these lamps, of course, again, against an extra cost, but at least we were able to increase quality and lifetime. So you can see if you don't do this, a lot of heat is being stored here below, but due to the addition of the heat pipes, heat is distributed. Also here allowing for a lower temperature at the LED at the bottom and making sure the cooling works better. If you buy today an LED fixture, you might have been scared about all the improvements in efficiency over, for example, compared to today to last year. How to cope with that? We offer our customers the possibility to make the LED engines upgradable. That means that if you have this fixture, and I just took a LED engine of last year's edition of our old fixture basically, but this LED engine is screwed inside here with 4 screws. With 8 or 10 screws we can remove the lens, we can remove the LED engine, we can swap it without the need to throw away such a cooling body, which is basically functioning very properly. The technology is inside here, so we are able to recover that, also allowing our customers to have lower costs over time. External power supplies. So when you put your 400 volt on this LED engine, it breaks down immediately. So what do? We put a power supply between the 400 volt and this fixture. So this power supply is separate. It's not integrated in the fixture. Why not? Because this is the first thing that breaks down. Typically, LED warranty is 10 years. This LED warranty is 5 years. So you see the difference. If it breaks down, this is typically the first thing that goes bust. We can swap it without the need of throwing away a complete fixture. Also, that is good for everybody's wallet and the environment. We also design our grow light rigs with a wireless control system. That basically means that we have one gateway sending out signals to the boosters in the stadium, making sure that we can keep our grow light rigs as simple as possible with as least failure modes as possible, increasing quality, but also ease of use, so you can control the boosters behind your computer, telephone, whatever. So how does the future of lighting technology look like? So we've seen in the past, we were used to a fixed light spectrum, the HPS-SON-T. After that, the fixed light spectrum was introduced in 2020. Quite soon, scientific results showed the benefits of having a dynamic light spectrum. So since 2022, Mechatronics hardly sold any non-controllable LED lights in the market. And yeah, this year we have the 4-channel controllable light spectrum introduced with 18% efficiency gain. Stogger, we have a team of combined experience, 150 years of engineering experience, 20 plus engineers in our team, and we offer our clients unmatched world-class engineering. And I would like to show you a short video how we do that.
At Stogger Turf Care, engineering is at the heart of everything we do. Our team combines precision design with cutting-edge technology to create turf care machines that are not only powerful, but also smarter and more sustainable. Every detail is engineered for efficiency, durability, and ease of use, setting new standards in the industry. What makes Stogger revolutionary is our ability to merge innovation with real-world performance, delivering solutions that transform the way turf is managed. We're not just building machines, we're shaping the future of turf care. Our innovations help professionals save time while achieving higher quality results. They are built to adapt to modern challenges and changing environmental demands. With Stogger, excellence is not a promise, it's a guarantee.
A product spectrum. So we worked very, very hard to have a complete product spectrum because we see that each customer has different needs. We have a booster compact, smallest grow light rig, very high light output. Also, the light is 1.5 meters above the pitch, being able to cover about 12 square meters, high intensity, quick results. We have the Booster Carbon Compact Plus, just launched here in Basel yesterday. It has a similar concept, easy to use. Also here, high intensity, close to the pitch lights. And in this case, the amount of light doubles compared to the compact. So, the Booster 60, small, easy to use, lightweight, for 60 square meters. If you combine them in the goal area, you double basically the light intensity. The Booster 80, also here on the pitch, is basically an extended version of the Booster 60. 2 lights extra, 2 heaters extra. We have the Booster 70C, that's basically a canopy. It's a grow light on, it's basically a glass house with cloth on wheels, keeping heat inside, warmth, but also keeping the light inside, because a part of the light is being reflected in the skies, often seen when you come at night, you drive towards the stadium, see a lot of light. So all the light is kept underneath the cloth with the idea to have the maximum efficiency and also to hold temperatures. So if temperatures go down quickly in the night, temperatures are preserved, and also heat from the soil is being stored and captured. We have the Booster 130 under development. This is basically a render. We launch it by the end of this year. And we have the Booster 230, which is basically half of the Booster 460, which is currently in production. The idea behind this grow light rig is that if for whatever reason the Booster 460 is too big or you can't get it into the stadium, you can take a smaller version. Also here we use the carbon. Carbon is our patented solution to have long arms, very strong, out of one piece. We have the Booster 240. We have this in Jakarta. It's 3.5 meters above soil is the LED. Typically not suitable for Western European climate due to the absence of heat. But in Jakarta, you don't have this problem. So that's why we designed it for that project. And then we have our flagship, the Booster Carbon 460 S-Head. All arms are made from carbon, patented technology, out of one piece, very slim design. The ideas behind it that it's lightweight, easy to use. And you can see it here on the pitch. On the pitch is here the second generation. We are already working on our third generation. But yeah, very thin, slim, slick design. Also working on our turfboard matrix. We have already sold 4 pieces of it, which we will be supplying by the end of the year to our customers. The idea behind this is that it's a carrier of something. In this case, we have designed an UVC light under it because you don't want to treat UVC, preferably during the daytime, because during nighttime, UVC is treated 2 times more effectively. Additionally, the cost of a robot is mainly in the robot itself, not that much in the carrier underneath. So that's why we're developing a concept where you can have different add-ons to the robot, making good use of the robot technology. We are securing and working on partnerships. Wildwood Machinery is our partner in the UK. Very proud on that one. Heiler is our partner here in Germany. We're working with Turf Talents in North America, but we also are open to cooperate with companies like Turf Coach, which have online platforms. People, groundsmen, are using different platforms, and we want to be able to connect with those platforms because we understand that our customers are not looking to have another platform to control your, for example, your lights. So that's why we want to connect with those existing platforms and integrate the boosters for the ease of use of the grounds manager. We also secured an innovation partnership at Bayer Leverkusen, our latest customer. Also very proud on that. So we asked them for advice on developing products, but we also launch them there, get valuable feedback. That's also the project which we are delivering now. They bought 3 booster 460s, the big ones, and they acquired 4 booster 70C, the 10s. DHL Stadium, Cape Town, South Africa, that's what we are going to supply. As well as, and we are super proud on that we secured a World Cup stadium, Vancouver, BC Place, Canada. Organizing this event was hard work, but that was also hard work. Super proud on that, and we will be supplying it at the beginning of next year. So Stogger is also present on the FIFA World Cup. So that was my presentation. Does anybody has questions? So the question is, do you use the heat of the LEDs to lower the need for warmth, basically, yeah? That's correct. So we have multiple grow light solutions. So I think the best example there is the 70C, for example. We basically capture the heat. So we also capture the heat produced in the grow light. Yes, so there's less need to have the heaters on. So that's correct. And typically in the morning we use, for example, the heaters to open the stomata to make sure that the processes are running, starting. But quite soon when that happened, we put them off to lower the need for heat. So yeah, you will notice when you have your hand towards an LED, there's definitely radiation. You feel the heat. So yeah, in the end, that benefits, definitely. So answer is yes.
Do you know how much electricity is used here in Basel each year for the systems?
I haven't got feedback, so that depends on the amount of hours, but we can read out individually the amount of lighting hours, the amount of heating hours. We are introducing that into our platform to calculate that, because it is a difference if you in the morning start up the lights, that consumes, for example, less electricity compared to during daytime at maximum growth capacity. So yeah, that's we don't get this information yet from Basel. Anyone else? I would like to thank you for your attention.